Okay, Assalamualaikum dan selamat tengah hari. Can you hear me? Okay, good. So since we do have only 30 minutes for the revision, so I do hope that every one of you already have the exercises question with you. Okay, this is to summarize all the chapter 4, which is active filter. Okay, so I will summarize everything so that if let's say you have any question, just ask. Okay. Okay, everyone can see the screen or not?
And
Okay, good. Okay, so for today there is the revision tutorial and exercises discussion related to active filter. Okay, so this is based on the exercises summary of active filter. Okay, the list of the questions that have been uploaded earlier. Okay, so that we move to the first question on active filter. Okay, before that, please be reminded that every one of you should have the list of the questions so we can have a look and solve everything together. Okay, so for active filter, question number 1, state the function of the filter. So this is basically
where to get the question?
sorry,
Where to get the question?
in e-learning. The last class I already said that every one of you should download the question in from the e-learning. That one has been uploaded earlier since our last class.
Yang exercise summary gitu.
Yes, question 1 up to 12.
Okay. Ada.
Okay, that one has been uploaded earlier since our last class. Okay, so for active filter, the first one is state the function of the filter. So I'll put here in the point form, which is the first one is passing signals within a band, frequency selectivity, rejecting or block the signals, and also extract past certain frequencies, which is our desired frequencies, and blocking or attenuate undesired frequency. This is basically the function of the filter. Okay, next is question number 4. Sorry, question number 2. Based on following figure, state and briefly explain 4 categories of filter. So I'll put here first, second, third, and fourth. Okay, basically we do have the low pass, high pass, band pass, and also band stop filter. Okay, this is the 4 categories of the filter that we have, right? So next we move to the next question, which is question number 3. Okay, before that, this is the categories. Okay, low pass, high pass, band pass, and also the band stop. Okay, this is A, B, C, D. Okay, based on this figure. Okay, next is question number 3. Explain your understanding based on following circuit. Okay, we do have the circuit in A and also the circuit in B. Right? So for this one, we can say that, okay, we do have the combination of RC. This is also R and C, but the only difference is the additional components, active components here. okay, which is the difference from A to B. Okay, so from this, okay, from this, we can see that this is active filter. Okay, we have the active filter compared to passive filter. Why? Because when we have this additional active component, that one become the circuit become the active. So because this is the filter circuit, so this is the active filter. So I just list down, okay, all the difference between the active filter and also the passive filter. Okay, for A, we can say that this is active filter by having this active component. And then for B, this is passive filter because we only have the lump elements, which is R and C without any active element. Okay, so from here, we can see that this is the active filter, use an active component, use a passive component for passive filter, high gain for active filter, low gain for passive filter, easy tuning for active filter, tuning is not easy, uneasy for passive filter, cheaper for active filter, more components, more cost. And then for the last one, active filter, frequency response is sharp, and this is less sharp. Okay, basically this is the table to interpret the difference between active filter and passive filter. Okay, any question for the first three questions? Anyone okay?
Okay.
Everyone okay?
Okay.
Okay, good. So next we move to question number 4. Illustrate in details, okay, with complete tables. Okay, with complete labels, meaning that you have to draw and label. Okay, so for this one, illustrate in detail with complete labels the general diagram of active filter. Okay, so this is the general diagram of active filter. Okay, so for active filter, from this illustration, okay, we draw everything and then put the labels. Okay, we do have the amplifier. This is the amplifier. Then we have the negative feedback circuit. This is negative feedback circuit. And then we also have the RC circuit. Okay, so basically this is the general diagram for active filter. Okay, so here we can see that this is the amplifier, this is active filter, meaning that this is the active components. Okay, so from this figure, we can say that this is the active filter, which consists of the amplifier, negative feedback circuit, and also the RC circuit. Okay, next we move to the question number 5. Okay, question number 5, we can see that the question is state the 3 characteristics of filter response and sketch on one graph. Meaning that all the 3 responses that we have is sketched on the same X and Y axis. Okay, so from here we can see that we have the Bessel characteristic, we have the Butterworth characteristic, and also the Chebyshev characteristics. Okay, then this is the purple one represent the Butterworth, the blue one represent the Bessel characteristic, and the green one represent the Chebyshev. Okay, so this is 3 characteristics of filter response. Okay, next we move to question number 6. Okay, this is the calculation question. Okay, so for this question, okay, given a Sallen-Key low pass filter, given a Sallen-Key low pass filter circuit, has the following parameters with the value of Q is 0.7071. Okay, basically if for Cellen K, we use the Butterworth table. Okay, actually this Q, I have explained earlier in the class. So this value of Q you can get from the table. If not provided, then get the value from the table. If provided like this question, so just use the value straight away, right? So for this case, the value of Q is given 0.7071. So the other parameters are the critical frequency 4.75 kilohertz, R1 2.25 kilo ohm, CA equal to CB, okay, CA equal to CB with the value of 4.7 microfarad. Okay, next we solve this question for the first one. Okay, first, calculate the resistance values for RA and RB. Okay, so from this question, we can say that CA, okay, when CA equal to CB, meaning that equal to C. So that's why when we have this type of calculation, we have to interpret. Okay, my advice, if you get any calculation question, first of all, extract all the given information. Okay, so that you can match with the appropriate equation. Which equation in appendix you need to use? Okay, so that you have to extract all the information given in the question. Then you can choose the appropriate equation, so proceed with the calculation. Okay, so we move to the solution for the first one. A, resistance values for RA and RB. Since this is CA equal to CB equal to C, so we can say that our RA equal to RB equal to R. So from this value, okay, the given value, we choose the appropriate equation. So we can see that FC equal to 1 over 2 pi RC. Okay, this is the appropriate equation to get the value of R. Why? Because FC is given 4 point. This is our FC. And then the C value is given also 4.7 microfarad. So just substitute this equation and then we can get our R. Okay, so from this FC, okay, FC equal to 1 over 2 pi RC. We don't know what is R, so we just move our R here. R equal to 1 over 2 pi FC C. Okay, so we can get our value of R. Okay, from the given value, okay, from the given parameters value in the question, we can substitute all the values in the equation so that we can get our R equal to 7.13 ohms. Okay, just reshuffle the equation, then substitute the values, given values, so that we get the desired parameters. For this case, we got the value of R equal to 7.13 ohms. Okay, next we move to the gain. ACL. What is ACL? What is ACL? ACL is the closed loop gain. Okay, ACL means that closed loop gain. So from here, we get the equations actually. Okay, just substitute the value and then we should get this value of Q is given 0.7071. So that 3 minus 1 over Q, Q is equal to 0.7071, so that our closed loop gain is 1.856. Okay, for ACL, okay, we also can have another equation. Okay, this is the first equation for ACL because we use the Q. Okay, we know the Q, then we use this to get the ACL. But from this equation also, okay, we can get ACL. So from B, we get the value of ACL. Now we move to the next equation. The purpose of this equation is to get the value of R2. Why? Because we have R1 given, but there is no value for R2. So we know our ACL, we obtain the ACL value from B, then we have R1 given, this, we know this, and then just reshuffle the equation so you can get the R2. Okay? So how we do this? Okay, so ACL, okay, equal to 1 plus R1 over R2. ACL minus 1, this one bring here, so equal to R1 over R2. So we want to know R2, bring this R2 here, so our R2 equal to R1 divided by ACL minus 1. This is the equation after reshuffle. Okay, then we know already our R1 given is 2.25 kilo ohms divided by our ACL is 1.586. Okay, so minus 1, right? So we solve everything, we should get our R2 equal to 3.84 kilo ohm. Okay. So for this value, it depends on, like I always said, it depends on how many decimal points that you use in your calculation. As long as your outcome, your calculation result within this value range should be acceptable. Because if let's say you get 3.82, 3.83, 3.85, as long as within this value range will be acceptable. No worries on that. It's just the matter of how many decimal points that you use in your calculation. Okay, it's not too much from the final answer should be acceptable. Okay. Like I said just now, 3.82, 3.84, 3.83, 3.81, okay, within this value will be acceptable. No worries on that. Okay. So next is D, the new voltage gain if the value of R2 is decreased by 30%. Decrease means that you have to minus, okay? Decrease and increase. Decrease is minus or lower the value. If increase, meaning that you have to up the value. So for this case, decrease, so we have to make sure that our new value of R2 is decreased by 30%. So we do the calculation R2 30% times 3 from 3.84 kilo ohms, so we get 1152. So our new R2 will be, since this is decreased, so 3.84 kilo ohm minus 1152, we got the new value of R2 is 2.96 kilo ohm. It means that our R2 is decreased by 30%. Okay, please be reminded the term of decrease or increase. If increase, you have to make sure this is supposed to be plus. Increase, plus, decrease, minus. Okay, so for this case, we decrease the value of R1 by 30%, so we minus the value. This is our new R, which is 2.69 kilo ohm. Right, so after we get the new value of the R2, then we have to calculate the new gain as well. So our new gain, okay, closed loop gain equal to, we use the same equation here, bring it here. So 1 plus R1 over R2 equal to 1 plus 2.25 kilo ohm. Use the same R1. There is no change for R1. So we have only the new R2, which is 2.69 kilo ohm, so that the value of ACL, the newest one, will be 1.836. Okay, so this is the importance of the term decrease or increase. Please be reminded on that. Decrease minus will be here, increase plus will be here, right? Any question for this? Any question?
Okay, madam.
Okay, good. Okay, next is with question number 7. With the aid of diagram, compare the Salenki low pass filter to the Salenki high pass filter. Okay, so Salenki means that this is the two-pole active filter. Salenki means two-pole active filter. Doesn't matter this is low pass or high pass. Please be reminded that for low pass filter or high pass filter, if mentioned Salenki, meaning that this is two-pole active filter. Right? So for this question number 7, we need to compare the low pass and high pass filter for Salenki. Right, so this is the figure for that. Okay, aid of diagram means you have to draw. With the aid of diagram means that you have to draw. Okay, this is the Salenki low pass filter. This is the Salenki high pass filter. This is high pass, this is low pass. Okay, please memorize how it looks like. Okay, the first one is two-pole. Okay, low pass filter will be, the circuit will begin with the R. Low pass, the circuit will begin with R. R, this is C, this is RB, this is CB. But for high pass filter, we begin with C. CARA, CB, RB, right? So this is one pole, this is another pole. Okay, so please memorize the circuit. Meaning that for low pass filter, we begin the circuit with the combination of RA and CA. The second pole is RB, CB. But for high pass filter, the other way around. Meaning that we begin with CA and RA, CB and RB for second pole. This is our first pole. This is second pole. Right? So next we move to the question number 8. Draw a schematic diagram for 6th order high pass filter cascade and explain its connection to the negative 120 dB per decade. So this one you also can refer to the lecture notes, right? I don't go further in this discussion since that you can get this information straight away from the lecture notes. So I just go through a bit on this. So 6th order meaning that we have this is 2, this is 2, and this is another 2. So this is 6th order. Okay, the combination of cascade from the first, second, and third, 2 poles, and another 2 poles. So it becomes the 6th pole or 6th order filter. since we begin with C1 R1, here, the combination of C2 and R2. So from here, we can see that we begin with C. That's why we have the high pass filter. Okay, refer back to this basic. Okay, RA, CA, RB, CB, this is low pass. Begin with CA, RA, CB, RB, this is high pass. So for question number 8, we can see that the requirement is for the high pass filter. That's why we begin with C1 R1, C2 R2. Also for the rest, right? So this is very important understanding required. How to differentiate or how to draw the circuit for low pass filter and high pass filter. Okay. So question number 9. Name all 3 Sallen-Key design simplifications. Okay, so there is 3 methods I'll put here. Okay, we did all the example already in the class. So for method number 1, assume equal value for filter component R and C. Then second method is for gain equal to 1, voltage follower, assume ratio value for filter component R and C. And then the final one is method number 3, assume equal value for filter component C and ratio value for component R. The most important thing and basic analysis normally referring to this method number 1. Okay, method number 1. Next, question number 10. Okay, so design a Sallen-Key low pass filter with the critical frequency FC equal to 8.51 kilohertz. Like I said just now, if you get the calculation question, first of all, extract the information given. Okay, because we want to suit with the provided equations. So which equations that can be used to solve this question? So from here, we can see that this is low pass filter. Given low pass filter frequency, critical frequency 8.51 kilohertz, design simplification, assume equal value for RC component, which is method 1. Okay. And then use the quality factor Q value that obtained from table 1 Butterworth and give the equal capacitor value 15 nanofarad R2 equal to 5 kilo ohm. Then sketch the circuit diagram of the filter by stating the parameters value. Okay, so for this case, Q is not given so that we can refer to table 1 Butterworth. Okay. Previous question, Q is given straight away, 0.70071. So you can use straight away. But for this case, you have to pick your Q from the table. Okay, this is the table 1, Butterworth filter table. So Sallen-Key means that 2 pole second order. So the value of Q, we get 0.7071. Okay. 2 things here. The first one is previous question given straight away Q 0.7071. But for this case, you have to refer to the Butterworth filter table. But the outcome still the same. Only the way of you obtaining the Q value. Okay, if not given, then you have to refer to the table. If given, just use the value straight away. Right? I hope everyone will understand, okay, how to get the Q value. Okay, next we move to the solution. Okay, Sallen-Key low pass filter. Okay, given this is the extraction from the question. Like I mentioned earlier, you have to extract all the given information. Given FC equal to 8.51, RC equal value, and then Q get from table 1, and then C equal to CA equal to CB, 50 nanofarad, R2 is given 5 kilo ohm. So we assume that because this is use method number 1, we assume RA equal to RB equal to R, CA equal to CB equal to C. So from this, we get our FC equal to, from this information, we get the FC equal to 8.5 kilohertz. To get the R, like the previous question, we reshuffle the equation. So from this, after substitute all the values, we get our value of R equal to 1.25 kilo ohm. So our RA equal to RB equal to R is equal to 1.25 kilo ohm. Okay, next is negative feedback circuit. Okay, from table, we got the Q equal to 0.7071. So this is the equation how to get the closed loop gain. Okay, non-inverting, so we get 1.586. Normally, if let's say Q equal to 0.7071, we can expect the ACL and I is equal to 1.586. Because this is fixed, this is fixed, this is referred to the table so that you get the value of closed loop gain is 1.586, right? Then we move to the ACL and I, okay, which is another equation here. Okay, so from this equation, we want to get the value of R1 since R2 is given. So our R1 equal to 2.93 kilo ohms. Okay. So after we complete all the calculation, then because from the questions state that sketch the circuit diagram of the filter by stating the parameters value. So you obtain everything from here, then you just put in the diagram like this, right? So this is what we obtain from the calculation and also the given information. So this will be the last one you have to do for this question. Okay, put the value for everything, RA, RB, CA, CB, R1, and also the R2. Okay, so this is completed the question number 10 requirement, right? So question number 11 is calculate the all required values to produce a Butterworth response with a critical frequency of 3325 Hertz. Okay, if all resistors is in RC low pass circuit, okay, the same thing. You may refer to the example. We also do the example for this in the class. Okay. So for this one, we have the fourth order. Okay, this is 2 pole, this is 2 pole. So we have two value of Q, okay, Q1 and also the Q2. Okay, the calculation is the same. Extract all the information for the first one, 2 poles. So you get all this value, right? You get all this value. Then when you calculate everything, so when we move to the stage number 2. For stage number 2, okay, if stage 1, we use the value of Q is 0.5412, okay, here. But for stage 2, we use the value of Q is 1.3065. Okay, this is the difference. Okay, this one refer to this Q, this one refer to this Q. Okay, because this is 2 pole, this is 2 pole, meaning that this is fourth order. So that's why we have two value of Qs. The value of Q at stage 1, the value of Q2 at stage 2. Okay, my advice, please redo the example that we did in the class previously, plus this, how to solve this question as well, right? Okay, next is the final question. Okay, this is question number 12, right? So for question number 12, this is how to plot the graph on a graph paper. Okay, so this is the following table shows the outcome from an experiment. Fill in the table and plot a graph on a graph paper. So for this one, we are using the semi-long graph paper. Okay, please enhance your skill how to draw the graph. Okay, so for this one, for this question, we have the frequency. Okay, this is the same question or practice in the lab session. Okay, might be only the different value is the frequency. Okay, and also the type of obtained filter. Okay, this is the different. Okay, for this case, use your last 4 digits of your matrix number as a cut-off frequency. So I'm giving you 7717. But if let's say your last number of your matrix number is 1, 2, 3, 4, so you use this frequency. Okay, read the question properly. It might ask you to use your last matrix number. It might ask you to use the odd or even numbers, and then it might have another requirement. So please read the question properly. Okay, so for this case, since they are saying that 4 digits of your matrix number, I'm giving you an example, for example, 7717. If your matrix number is 1, 2, 3, 4, you use 1, 2, 3, 4. If your final, the last 4 digit of your matrix number is 7, 2, 3, 3, then use that value. Okay, so every one of you, for this case, supposed to have different value, right? So from that, you already have your cutoff frequency equal to 7717 hertz, right? Then calculate this value. 1 over 16 times by FC, which is 7717. So you get the value of frequency equal to 482, right? And then given this is given, we in given, we out given. So AV equal to V out over V in, from this is V out over V in. So you divide this and this so that you get 1.173. Then convert to dB, 20 log AV. Okay, 20 log 10 AV. So from this, you get this value, right? And then by having all this, okay, you get the frequency, you get all those V in, V out, complete everything. So this is the final value for the table, right? So after completed everything, because the information given for this question is only this is your cutoff frequency, then you can calculate all the rest of the frequency. So you are given V in and V out, so you calculate the AV, then convert the AV to dB, right? So you complete everything, then plot the graph. Okay, this is the graph that I'm plotting for you. So my advice. Okay, first of all, when you have this kind of, I think during the lab session, most of you have the difficulties to put the scaling on X and Y axis. Okay, so Y axis supposed to be gain in dB. Okay, AV dB. This is your frequency. First of all, when you want to put the scale, okay, you have to know what is the highest value. For example, frequency. Okay, so go to frequency. The lowest value is 400 plus, and then the highest value is 61K. So that for this one, you can begin from 0, you can begin from 100 or 10. Okay, for my case, I just, since this only used up to 100K, so I begin with 0. But if you want to begin with 10, also fine, right? So for this one, we can see that for semi-long graph paper, we begin with the bigger size of box, okay? Then up to small size. So if you begin with 10, also fine. If you begin with 0, also fine. For this example, because I want to put my graph in the middle of the graph paper so that I put 0, 10, 100, 1K, okay, 10K and up to 100K. Because our lowest value is 482 and then the highest value is 61. So that from 0 to 100K. After plot everything, then don't forget, okay, we have negative 3 dB. How to get this 3 dB? So go to your highest value. Highest value is 1.39. Okay, this is the highest value, 1.39 dB, then minus 3 dB. Okay, minus 3 dB, right? So that here you can get this is your 1.39 minus 3 dB so that you get negative 1.61. So this is negative 1.61. Do the projection, then you got the value. So from this, we can get that the negative 3 dB after your highest point 1.39, so you get your frequency around 4.1 kilohertz. Right? So this is the completed table. Do the projection. Okay, for negative 3 dB. Use your highest point minus the negative 3 dB, then you get another value which is negative 1.61. Then do the projection, you get the value of F equal to 4.1. If let's say you get 4.3, 4.5, also fine. Depends on how you plot the graph. Okay, the value totally depends on how you plot the graph using your obtained value. Right? At the end of the day, you get the shape. Right? Okay, done.
Okay.
Any question?
Ada, madam.
Everyone clear?
Clear.
Okay. Any question before we dismiss? Last one. Any question? Everyone okay?
Okay, okay.
Okay, so I think that's all for the revision for active filter. So if let's say you have any question, just reach me separately. Hopefully not